Okay, I think we can start. I did not complete the question answers from morning, so I think let's do that first. So let's see what's the question. You're given integer array nums and integer k and integer multiplier. You need to perform k operations on nums. In each operation, okay. Nums and integer k and integer multiplier from k operations on nums. Each operation find the minimum value x, mean value x. You need to perform k operations on nums. In each operation find minimum value x in nums. If there are multiple occurrences of minimum values, select one that appears first. Replace the selected minimum value x with x into multiplier. After k operation, apply model. Okay, fine. So input nums 2, 1, 3, 5. Okay. K equals to 5, multiplier equals to 2. So we got operation 1. Hmm. Find minimum value x in nums if there are multiple occurrences of the minimum value that appears first. Find the minimum value x in nums. Occurrences of the replace the selected so what's the minimum value here in the first one? 1. So replace 1 by 1 into 2, so that's 2. What's k actually? Okay, we have to perform 5 operation. K equals to 5. Again the minimum value is 2, 2. So I do replace all the minimum values. Okay, no, only one that appears first. So replaced it with 2 into 2, 4. Again minimum value this 2 and replaced again. Then the minimum value here is 3, 6, and then minimum value is 5. No, sorry, 4 becomes 8. Again 4. No, again now it's actually 5. Sorry, 4. Yeah, what happened? Okay, these are the 5 operations, and then we have to apply modulo of to every value in nubs. Okay, return the it here. Hmm. Why does it look easy to me? I don't know. 10 power 4, I can do it in n log n. So what if we make a min heap and keep on getting the minimum? and that should do it actually. Why do we? It's not at all difficult, right? Just take a mean heap, keep extracting, replace, and that's it. Priority queue. I don't even want to code this question, but I'm coding int creator int pq for int x in nums pq dot push x. So this is a min heap, right? Pq dot push x. What's the value of k? Sorry, the okay, I see the catch here. K is 10 power 9, so that means we cannot do this iteration, right? Now it makes sense. Now it makes sense. Okay, so we have to find some way to do this without breaking this constraint. Okay, I see. Uh, just give me 1 minute. Try to find a solution to this. I'll come back. Okay, I think uh, okay, I try to figure out. So k is very large and we cannot iterate. So is there some way Without iterating, can we get to these points? Okay. Okay, let's see. So if I have, let's say, three ones, and then I have 3, 4, 5, I get all the ones, and I keep multiplying them by 3, and then again I take a 1. You see how it happens? So all the occurrences of 1, they are just gone. Hmm. And then all the occurrences of let's see a hint maybe. I think we should try out first, then we'll try to get the hint. Okay. 1, 1, 1, 3, 4, 5. Let's say the multiplier is 3, and I know after the first move become 3, 1, 1, 3, 4, 5. After the second move it becomes 3, 3, 1, 3, 5, 3, 3, 3, 4, 5. 3, 4, 5 then becomes final. I erased it out. So what we know, one thing that you are afraid about is you don't know after multiplication where will it stand, right? Hmm. Will it be second? Will it be third? You don't know that, right? Okay, positions are fixed. Hmm. But how do I keep finding the menu? Ambaradichi. So values are going to get very big. How big are it? Is it going to become? K times I have to perform. Multiplier can be big. 6 is going to be huge number. बोला अरे नौटंकी करती. सब ऐसे स्ट्रांग हुआ करते तो बेंच गांड मार लेंगे. I think we'll have to check hints.
Hello everyone, welcome back. In this game, both second problem, the value of x is to return 10 power 9. So as always, we'll start from the very brute force solution, which would be sufficient for the first problem itself, and then we'll see how to optimize it step by step. The problem's there, answer, right? So what is the operation? Operation is you will find the minimum value x in the given array norms. If there are multiple of them, you will break the ties with the indexing and replace the selected minimum value x with x multiplied by multiplier. So you will keep on doing this for n k number of times, and whatever is the state, you will return that as the final answer. So one thing to note here is the modulus should be applied towards the end, because if you apply modulus along with the operation, the value finding out the minimum would be difficult. Basically, you will not, the actual minimum in the array can be something else, but because you applied modulus, you are not able to identify that. So the modulus should be applied in such a fashion that it should not interfere with the minimum value. So you can't simply keep on taking modulus along with the operation itself. So something you keep in mind. So let's take an example. Let's say nums is 2 1 3 5 6, k is 5, multiplier is 2. So we need to apply the operation 5 number of times, and the value of multiplier here is 2. So let's apply the operation. We'll first find the minimum value here. Minimum value is 5, minimum value is 1, so we'll simply multiply it with the multiplier, which is 2. So the array would become 2 2 3 5 6. Now again, let's apply the second operation. What is the minimum value? Minimum value is 2, so there are 2 2's. Which of them will we pick? The one which occurs first. So in this case, this one. So we'll simply pick this and multiply it with the multiplier, which make it 4. Now after that, we'll apply the operation here. Again, pick the minimum value, which is 2, multiplied by 2, which will make it 4. Now on this one, again, the smallest is 3, multiplied by 2, it will become 6. And finally on this one, the smallest is 4. There are 2 4's, which will pick the first one and multiply it by 2, and it will become 8 4 6 5 6. So after applying 5 operations, this is the state, and because none of them is greater than 10 power 9 plus 7, after applying modulus it will remain 84656, and that is our answer. So hope the problem statement is clear. Now what's the brute force way to solve this? The brute force way would be like just simulate whatever is given to you. So you have been said that okay, you need to apply 5 operations, so just apply the 5 operation in the given fashion. So in this scenario we'll pick the minimum value. Minimum element is 2, right? And you will simply multiply it by 4. So that's the end of one operation. Now you will apply the same thing again on this array, and so on and so forth until k number of times. So what's the what's the complexity of this entire brute force solution? You are doing something k number of times, right? Now each time what you're doing, you are picking the minimum element and then multiplying it by 2. So finding out the minimum element in this array, if you do it naively, it can take you order n time. You will simply iterate over the entire entire array and figure out the one which is the minimum value. So if you do it naively, this entire algorithm would take you order k into n time, which is sufficient for the first problem, because the value of k definitely will not work for just do this k into L. There are some ways in which you can optimize this n for sure, right? Like you
k इक्वल्स टू अगर 9 का पता है तो k इक्वल्स 10 का तो पता चल ही जाएगा, लेकिन उससे कुछ नहीं करना. अगर k इक्वल्स टू 2 का पता है या k इक्वल्स टू 3 का पता है तो k इक्वल्स टू 4 का पता चल सकता है. k इक्वल्स टू अगर 1 का पता है, सॉरी, k इक्वल्स टू n, k प्लस n का
you are doing a linear iteration to find the minimum value. There are better ways to do it using some sorted data structures. But even though you optimize this, it will not be of much value because the main culprit here is k. K is very huge in power 9, so you can't afford k. What does it mean? It means that you can't simply keep on applying the operation one by one. You need to somehow figure out a way to group the operation and apply them as a whole, right? Because if you keep on applying this operation one by one, you will take 10 power 9 iteration, and even if you do order one things in each iteration, this algorithm will not be sufficient. So grouping certain operations, what does it mean? It means that you need to somehow know, okay, on this index I will multiply this multiplier x number of times or exponent number of times. On this one I will apply the multiplier extra number of times, and so on and so forth. So this problem in general is looking hard. So whenever you face this kind of issues, try to either reduce the number of variables you have, or try to solve the same problem on a smaller array itself. So basically try to reduce the problem and solve the smaller version first before jumping to the original problem itself. So let's do the same. In this scenario there are not much variables, so we'll try to reduce the array size itself. We'll simply say we'll first solve the same problem on an array size of 2, and if we are able to do so, we'll try with 3, and then we'll see if we can generalize whatever solution we have so far. So we need to solve the same problem on this 2 element array, and let's assume that m is 2 and k is 100, right? So we need to come up with some sort of algorithm wherein k is not there in the time complexity at all. That
okay. How many times will I multiply m here and m here? So if I multiply x times over here, I'll multiply 100 minus x times on the second index. Okay, and now I need to find out what will be x. Okay, So whenever this thing is less than this thing, we can keep multiplying here. So initially it'll become 8 7, smaller it'll become 14 8. This is 16 14. Okay. So So x will be the number of times this index is less than that element. So we know. Let's see. What if? Mhm. How will this grow? 4, 8, 16, then 32, then 64, 128. How will that grow? 7, 14. 28, 28 256 x bar 224, and then 4, 4, 8, 256. This is how this is grown. Mm, 1 2, so 2 arrays. the multiplier is same, right? Mm, 2 over 2 be a 7. Will always be less than 8 into 2 power x, correct? 10 to power 3 plus 6. 7 into power x will always be less than 3. Okay, but what if this was 9? This will be always less than. Less than x plus 4. This is it. So the plus 3 to power x plus 4, right? Less than this. Take this, you take this. So we take this, we take this, 2, 3, 4, 5, 6, 8.
That's our goal. So if you haven't tried this version of the problem yet, this is the right time to pause and try to give it a try to solve the problem for this 2-element version by yourself. The main thing to notice here is, let's say you apply the operation here, so this will become 8 and this will become 7. Now the smallest element would become 7, so you will apply the operation on this element now. So basically this will become 14 and this will remain 8. Now this will become the smallest element, so you will apply the operation here, this will become 16, this will become 14. Now you will apply the operation here, this will become applying the operation on every element in every alternate turns. So in other words, you are applying k by 2 operations here and k by 2 operations here, and then whatever is remaining you will apply starting from here, because this is the smallest element which you have started with, right? Now why is this the case? Like, will this sequence exist forever? That's the first question. Second, will this always be the case that you will apply operation, like once you apply the operation on the first element you will have to apply the operation on the second element, because now second element is become greater? So the answer for second question is simply false, because you can see even in this small example, if you apply the operation on the first element, this will become 2 and 7, and after this you will not apply the operation on 7, rather you will again apply the operation on 2 itself, because 2 is there. This is happening once. Will it happen forever or not? So in this scenario, answer is yes. Why? Because you notice you are saying that there is some element, let's say x1, and you are multiplying it with m, and this is becoming greater than the second element, which is x2, right? Now this inequality is there. Now let's say you apply, because x1 was smaller than x2, as in like x1 here is 4 and x2 here is 7, so let's say this x1 is smaller, so you apply the operation on x1, this becomes something like this. In other words, your array is now m multiplied by x1 and x2, and because this inequality is satisfied, that's something you are assuming, you will now apply the operation on x2. So basically you multiply 7 by 2, which is 8 comma 14, which make it 8 comma 14. Basically what you have now is mx1 and mx2, right? Now which of these two will be smaller? The answer is surely mx1. Why? Because x1 itself was smaller than x2 in the very first case itself, because that's why you applied the operation on x1, right? So we know that 4 was smaller than 7, and hence mx1 would be smaller than mx2 itself. In other words, you will now be applying operation here. So if you apply the operation here, what would this now become? This would become m square x1 and mx2, right? Now the question really you need to answer is that if you keep on doing this, currently you can see this, okay, 16 is smaller than greater than 14, so you will now apply operation here. But will this always continue? In other words, would mx2 be smaller than m square x1 always or not? The answer is yes, because this inequality was true. Like, because you had set that you will apply the operation on this element now because of this inequality. This inequality will also be true. Basically, you simply multiply m both the sides and you will get with this exact inequality. And because of this, you know that this one will be smaller, and you will be multiplying m to this one now. And once you multiply m to this one, again both x1 and x2 are multiplied by m square, so whichever was smaller initially would be smaller now, and you will simply apply the operation on that one again. So you will simply apply operation on x1 now, and after this point, again with the help of this inequality, you can simply multiply m here. You can see that m cube x1 will be greater than m square x2, which means that you will now apply operation here. That is, you will make this m cube x2, right? Basically, you are simply alternating from this point onwards. So what we just proved is, if this inequality is true, that is, if after applying one operation this becomes greater than the previous one, the largest one that exists, we are sure that we will simply be alternating the operations one by one. If this is not clear, rewind the past 30 seconds and you will be able to understand this with if it's still not clear, I would encourage you to try it on a pen and paper, and I'm very sure you will get it. So what we just proved is, if this inequality happens between these two elements, I know how to solve. I can simply divide my operation half and half, and whatever is remaining I will is was the final 7 multiplied by 2 power 50. So this will be your final array after 50. 4 multiplied by 2 power 51 and 7 multiplied by 2 power 50. The apply here because this one was the smaller one, right? So overall, at the end, your final multiply after what is the overall time complexity now? Smaller one. So this operation of dividing things is simply order 1, fast exponentiation. So for b in log b time instead of this k itself. Now this all things were true when the inequality that m x1 is greater than x2 was true. But if this inequality is not true, this will and just in the PI operation here, this becomes 2,7 criteria 2, because now let's say you apply the operation here 2,7. Is the inequality satisfied? The answer is no, because m cross x1 is 4 and x2 is 7. So again 4 is not greater than 7, and because this inequality is not satisfied, you are sure that you will be applying operation on x1 itself, right? Because if the operation here is not satisfied, after applying some operation we were able to get to a state itself. So after this, able to reach this state first. Second, how many operations will be there to reach this state? Because if the number of something small, so if m is log of x1, mean that you multiply m, this would grow above x2. It's possible k by 2 in log k time. So this is the overall complexity, and we are not optimizing this because this is k time. time will it take to hit this inequality? Log of x, because after that you are sure that this x1 would be greater than x2 for sure. So overall, what you're doing log x operation. Each operation, if you do naively, that will take order and time, but as we discussed, we can make it log n as well, if needed, with the help of some set or any ordered registers. So overall, n into log x time plus log k time, because after you did all of these, you will simply keep alternating and figure out 2 power k by 2 in log k time. So this is the overall complexity, and we are not optimizing this because this is well within the time constraint, so this will work. But this entire thing is for an array of size 2. So next we're looking at how to solve it for array of size 3, and then we'll try to generalize it. So I would strongly encourage you to pause and try to like look at these two examples only and see if you are able to proceed.
Okay. It's an
for an array of size 3 by yourself or not. So again, we have to come up with an algorithm where k is not there, or rather we are not applying operation k number of times one by one.